Picture this. You sit down in the exam hall. The invigilator says you may begin. You flip open your Cambridge IGCSE 0580 mathematics paper, and there it is. The boogeyman. Those massive, multi-step, complex word problems involving ratio, proportion, and compound measures. I see two types of students tackle these. Let's call them Alex and Sam. Now, Alex is a walking textbook. Alex overloads on raw math facts, memorizes every formula, but completely freezes when a word problem asks for actual analysis. Then you have Sam. Sam is a speed demon. Sam rushes, completely misses the command word requirements, and throws away easy marks on silly mistakes. Today, we are going to make sure you aren't an Alex and you aren't a Sam. We're going to build a tactical toolkit to absolutely dismantle these questions. When this exam pushes you out of your comfort zone, you are going to push back with perfect, full-mark answers. You're going to become the John Wick of grades. Let's dive in. Consider this your ultimate mission briefing. We are going to systematically break down 4 critical areas today. First, direct proportion strategies. Second, the logic flip. Third, the scaling trap. And finally, boss formulas. By the end of this explainer, you'll have a clear system to decode exactly what the examiner wants, so you can turn all that exam anxiety into pure problem-solving confidence. We are going to transform those red pen marks into green check marks. Let's get right into it. Section 1, direct proportion strategies. We are starting with our core foundational weapons. Direct proportion is the baseline. It simply means that as one quantity increases, the other increases right along with it at the exact same rate. If you work twice as many hours, you get paid twice as much money. But Cambridge examiners don't just hand out marks for knowing what direct proportion is. They test your execution. Let's look at a classic Cambridge past paper scenario right here on the screen. A bottling machine fills 500 bottles in 15 minutes. How many bottles will it fill in 1.5 hours? Now, if you are like our student Sam, your brain immediately starts rushing. You just see the numbers 500, 15, and 1.5, and you start multiplying them together. Stop right there. Look at the command words and the data. The examiner is actively trying to set a trap. You absolutely must first convert that 1.5 hours into 90 minutes before you even touch a calculator. If your units don't match, your final answer is doomed from the start. Okay, once you've dodged the unit trap, how do we actually solve this? The beauty of math is that you have options. On the left side of your screen is the ratio method. This is where you set up an algebraic equation, basically saying x over 90 equals 500 over 15, and you cross-multiply. It's clean, it's fast. On the right side, we have the unitary method. This is brilliant if you want to really visualize the problem. You figure out exactly how many bottles the machine fills in just one single minute, and then you multiply that base rate by your 90 minutes. I want you to pick the weapon you are most comfortable with and master it. Whichever method you choose, crunching those numbers leads you straight to a perfect 3,000 bottles. You see, once you decode the command, match the units, and apply a structured framework, the math itself is a breeze. That's how you secure those early marks without breaking a sweat. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving right along to Section 2, the logic flip. This is where the difficulty ramps up and where I see so many top students suddenly drop marks. We are entering the territory of inverse proportion. If you run on autopilot here, you will fail the question. So what is inverse proportion? It's when an increase in one quantity causes a proportional decrease in another quantity. You literally have to flip your exam logic upside down. Think about it realistically. If you hire 10 extra people to help you paint a house, it's going to take way less time, right? Not more time. The variables are moving in totally opposite directions. If you try to use the direct proportion formulas we just learned, you're going to tell the examiner that hiring more workers makes the job take longer, which makes absolutely zero sense. Let's do a quick data scan challenge. Look closely at this table on the screen. What is the core trend happening here? When the train speed doubles from 60 to 120 kilometers per hour, what happens to the time? It halves. It goes from 2 hours down to 1 hour. And if the speed drops to 30, the time doubles to 4 hours. It's a perfect mathematical seesaw. As one side goes up, the other side comes down by the exact same factor. Let's put this logic flip to the test with another word problem. If 8 people can pick apples in 6 days, how long will it take 12 people? Now, this is where we use an adapted PL framework for math. Point: identify that this is inverse proportion because more workers means less time. Evidence: we have 8 people and 6 days. Explanation. This is where we show our exact calculation steps. Link. We will check if our final answer logically makes sense at the end. Here is the absolute best way to explain your working for inverse proportion. Calculate the total effort required. If it takes 8 people 6 days, imagine just one poor guy trying to pick all those apples by himself. He would have to work for 48 days straight. We found that by multiplying 6 days by 8 people. That 48 is our magic number. It's the total man-days of work. Once you have that massive total effort number, you simply divide it by your new, larger workforce of 12 people. 48 divided by 12 gives us 4 days. And let's link it back to check our logic. Does it make sense that 12 people finish faster than 8 people? Yes, 4 days is less than 6 days. Flawless logic. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Welcome to Section 3, the scaling trap. If inverse proportion is a hurdle, the scaling trap is a massive pitfall covered in spikes. This catches countless students off guard when they are dealing with geometry and dimensions. Let's make sure you aren't one of them. All right, time for another challenge. Find the flaw in this thinking. Look at the question. A 7 centimeter by 4 centimeter rectangle is enlarged by a ratio of 2:1. By what ratio has the area been enlarged? If you ask our student Alex, he'll say, well, the sides doubled, so obviously the area just doubles too. Boom, 0 marks. Why is Alex completely wrong here? Because he is ignoring the dimensions of the shape. Here is the absolute golden rule for scaling that you need to memorize. You must respect the dimensions. A simple line is 1D. If a line doubles, it just scales directly by the ratio. But an area is 2D. It has length and width, so you have to square the ratio. And if the examiner throws a 3D volume question at you, like a sphere or a cylinder, you have to cube the ratio. It's a massive multiplier effect that completely changes the math. Let me prove it to you. The original rectangle is 7 by 4, so its area is 28. If we double the sides, they become 14 and 8. What is 14 times 8? It's 112. Now, is 112 just double 28? No way. It's exactly 4 times larger. Because both the length and the width doubled, the area scaled at a 4:1 ratio. 2 squared is 4. That is the scaling trap. And now that you've seen it, you will never fall for it again. Finally, we have reached Section 4, Boss Formulas. You've made it to the final stage of the explainer. This is where we master compound measures. When you conquer these, you are securely planting yourself in the highest grade boundaries of the 0580 syllabus. Why do we call them boss formulas? Because compound measures are exactly that. They are compounds. They take 2 or more totally different measurements and smash them together into one concept. You aren't just looking at distance anymore. You are looking at distance over time to find speed. You aren't just looking at mass. You are looking at mass within a specific volume to find density. It's multi-layered, which means it's easy to get lost. But don't panic, because I'm giving you the ultimate visual cheat codes, the formula triangles. You've probably seen these before, but are you using them under exam pressure? Simply cover up the value you are trying to find with your thumb. The triangle then visually tells you exactly what to do with the remaining 2. If they are side by side, you multiply. If one is on top of the other, you divide. It completely eliminates formula memorization anxiety. Okay, I'm virtually putting 30 seconds on the clock for a speed writing challenge. Look at this massive multi-step scenario. A building company wants to add houses to an 8 square kilometer village of 540 people without exceeding a population density of 110 people per square kilometer. How many extra people can it have? Identify the command, grab your formula triangle, and structure your attack right now. Time's up. Let's break it down perfectly. First, we use our population triangle. We need to find the absolute maximum population allowed. Population equals density multiplied by area. So we take the max density of 110, multiply it by the area of 8, and we get 880 people total. That's the absolute ceiling. Step 2, the command word asks for extra people. So we take that 880 maximum and subtract the 540 people who already live there. And boom, 340 extra people. Look at what we just did. We took a terrifying paragraph of text, identified the compound measure, used our visual cheat code, logically separated the steps, and perfectly extracted the final answer. No panic, no rushing like Sam, and no freezing like Alex. Just a cold, calculated, perfect answer that guarantees maximum marks. By mastering unit conversions in direct proportion, spotting the inverse logic flip, respecting dimensional scaling, and leaning on your formula triangles, you are fully equipped to crush these questions. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.